Sedimentary features. So bedding. Features help geologists interpret how sedimentary rocks formed. And bedding is a horizontal layering that is the primary feature of sedimentary rocks. And this results from the way sediments settle out of water or wind. So they're kind of layered one on top of the other, and that creates this sort of bedding, these layers that we call bedding. Individual beds can vary in thickness from a few millimeters to several meters thick. And then there are two main types. You have graded bedding, and then you have cross bedding. Now, graded bedding is bedding in which the particle sizes become progressively finer and lighter toward the top layers. Or you can think about it as you go down, the grains get bigger. So the grains are bigger down here towards the bottom, and they get finer as you go towards the top. So, commonly observed in marine sedimentary rocks deposited by underwater landslides, because you have landslides stirs up all this sediment, and then these larger particles can settle first, and then the lighter particles settle on top of them. So cross bedding is formed as inclined layers of sediment are deposited across a horizontal surface. This is commonly formed on sandy beaches, sandbars in rivers, and migrating dunes. So you have basically material that gets piled up, and then it gets piled up again, it gets shifted, and it forms these sort of crisscross patterns. So you have some of these patterns going this way, and then some going this way, and then some of these others are actually going the other way. So these crisscross each other. So how does cross bedding form? So imagine you have a dune here. Okay, so the sand carried by wind gets deposited on the downwind side of the dune. Okay, so the wind is blowing to the right. It's blowing all this sand across here, and it's actually getting deposited on the downwind side of the dune. Now, if the wind changes direction, well, now you get the dune forming this way. So our downwind side is over here. So you're getting these layers formed in this direction. So here's our cross bedding forming right here. Okay, cross bedding in streams and stuff can happen as well. Sediment on the river bottom gets pushed into small hills and ripples by the current. And then additional sediment gets deposited at an angle on the down current side, and these hills form cross beds. So you have these sort of cross beds forming here. Eventually it levels out, or new hills form, and the process begins again. So you may get new hills formed on top of that. So you got this sort of wavy pattern. Well, if this starts here now you got a wave coming up here that kind of comes down here. You got these cross beds forming. So ripple marks form when sediment is moved into small ridges by wind or wave action or by river currents. Back and forth wave motion creates symmetrical ripples, and then flow in one direction like a river creates asymmetrical ripples. And there's diagrams of that here in a second. So if the ripples are buried gently, they may be preserved in the rock. So you may get ripples in the rock similar to our example over here. So wave action is what this first one is. The left side of this is wave action forming ripple marks. So the back and forth wave action on a shore pushes the sand on the bottom into symmetrical ripples. Then grain size is evenly distributed. So basically what's happening is it's pushing it into ripples going one way, and then as the waves go back out, they're kind of pushing it back the other way, so that kind of evens it out. So you get this sort of symmetrical pattern. And then current that flows in one direction, such as a river on this side, pushes sediment on the bottom into asymmetrical ripple marks. They are steeper upstream and contain coarser sediments on the upstream side. Angular versus rounded. Some sediment grains have sharp angular edges, while others are smooth and rounded. When they first break off, sediment grains are angular. As the sediment is transported, though, additional pieces are broken off as the pieces bump into each other, and they become rounded. So the amount of rounding is related to how far the sediment is transported. And again, it's because they bump into each other and other pieces get broken off as they're kind of moving down the stream. Harder minerals with no cleavage planes like quartz have a better chance of becoming rounded before they break apart. If they have cleavage planes, they're more likely to break along those cleavage planes, and then you got these sharp edges still. But something that has fracture to it, you can actually break off chunks and have the whole thing be rounded. Our example over here, so quartz sand, the quartz sand could actually be more rounded because, again, it's made of quartz, and it's going to likely break off and smooth out before it gets sharp edges to it again. But something like carbonate sand down here, well, you can kind of see a lot of these sharp angular pieces, and that's because it's got cleavage planes that it's breaking along. Evidence of past life. So fossils are one of the best known features of sedimentary rocks, and fossils can only occur in sedimentary rocks because igneous rocks are totally molten, so any fossils will be destroyed, and the pressure and temperature changes required for metamorphic rocks would also destroy any fossils that were there. But fossils are preserved remains, impressions, or other evidence of once living organisms. This requires an organism's remains to be buried without being disturbed. And then during lithification, parts of the organism are replaced by minerals. So it's one thing to kind of note is this is either an impression of some sort, it's like a mold, or if it's bones like this, those bones are not actually bone anymore. They are minerals that have replaced the bone. But fossils provide evidence of organisms and environments from the distant past, including how organisms change over time. If you find a whole series of fossils, you can kind of tell how things change over time.